Hello friends, good morning. Today we will be discussing about a URL Shortener and then we will design a URL Shortener service. So first we will discuss in brief what is a URL Shortener. We will discuss about benefits of having a URL Shortener. We will clarify the requirement. So it is always a better option to first clarify the requirement with interviewer, discuss any questions, any doubts that you have before jumping onto the design and then log the requirement. So interviewer and the candidate both should agree on a final set of requirement, functional requirement as well as non-functional requirement, which should be considered while designing the system. And then we will discuss about back of the envelope estimation. What is it? It is a rough calculation which approximates some key metrics. It is a very important step in system design and it helps you take some important decisions. It helps you with some important metrics, for example, scalability requirement, bottleneck, trade-off, resource planning, etc. It helps you take the decision like should you go with monolithic, should you consider microservices for your system, or do you need to add a load balancer, do you need to implement a replication, etc. Then we will move on to the high level design. We will draw the high level architecture. We will discuss about the important concept like hash function, URL shortening API, URL redirecting API, and then we will deep dive into those concepts in more details. At last, we will talk about important questions related to hotkeys. So when you are in an interview, interviewer may ask you these questions. This is a very important topic, and we should be ready to answer that question. So let's move ahead and start with what is a URL shortener service. So what is a URL shortener? So it is a tool that takes a long URL as an input parameter and converts that into a much shorter version. And then when a user clicks on that short URL, it again redirects back to the long URL. So I can write it down, a tool that converts a long URL into a shorter version. Then when user clicks on that, then it redirects the short URL to the original long URL. Now, URL. Now, let's discuss some examples. So, for example, you have a long URL, https in dot wikipedia dot org slash some very long path. So, you have this lengthy URL that can be converted into a very short URL such as tiny url.com slash abc123. So this can be converted into this short URL. This is the domain. This is not necessarily a fixed domain. You can have a custom, you can design a system which will support the custom domain. For example, uh, this particular URL can also be converted into https double slash my wiki.com slash abc123. So this can be converted like this. And when user clicks on this link, the service will redirect user to back to the original URL. This is how URL shortener service work. Now let's discuss quickly some benefits of having a short URL. The first one is easy sharing. It is always easy to share a short URL on social media, on email, on SMS, etc. because it fits into the character limit. Then it improves the click-through rate because short URL is very clean and concise, and therefore it encourages user for more clicks comparing to the long, lengthy URL. Then the fourth one, tracking and analytics. I mean the third one. So it tracks information like number of clicks, geographical location, device, referral sources, etc. And therefore these are very important metrics to have, so it helps in that. And then the fourth one, brand recognition, branding opportunity. So as we discussed, the URL shortener service support custom domain, and therefore it enforces the brand recognition and trust. Last but not the least, it is easy to type manually, share verbally, etc. Print and etc. So these are some of the benefits of having a short URL. Now, let's clarify the requirement and let's lock, clarify some questions and lock the final set of requirement, and then we will move to the high level step. So, uh, first question, and the very simple question that you can ask interviewer is, share some example. Share an example. Now, as we had already discussed an example, so we will skip this question, but it is a very simple question, and it is perfectly fine to ask this question in an interview if you do not understand the problem correctly. Then, traffic volume. What is the traffic volume that we are planning to support for our service? So let's say 10 million URL generation per day, or probably 100 million URL generation in a day. Then discuss the next question with the interviewer, which are um, um, what are the characters allowed. So the next question can be, what are the characters allowed to generate a short URL? So let's say we are allowed to use numbers which are 0 to 9, and alphabet lowercase a to z, and uppercase a to z. So here you have 10 character, here 26 plus 26, and if you will add all of them, it will become 62 characters. So you are allowed to use 62 characters to generate a short URL. Now, um, and then you may have other questions as well. For example, should the short URL be updated or deleted? Answer can be yes. Your service to support that a short URL, already generated short URL, can be deleted or can be updated to a new version. But for the sake of simplicity, let's say we will assume that we are not going to implement that requirement, that functionality in our system. Now, let's move ahead and lock the requirement. So we have functional requirement. The number one, um, it should generate short URL for a given long URL. Then it should redirect short URL to the original long URL. So these two are the core requirement of a short URL shortener service. Other requirement, not a core requirement, but maybe good to have, is support custom domain, support URL expiration. These are optional, right? Now let's discuss about non-functional requirement. Okay. So the first thing is high availability. System should be highly available, because and in fact it should always work for redirect at least. So for example, a user have already generated a short URL for a given long URL, but when he or she clicks on that short URL, he is unable to go to the original URL, and this indicates that if such scenarios occurs, this indicates that our system is not very reliable. So we should take care of this, and our system should be able to support the redirect almost all the time. Then you may have non-functional requirement as consistency. So suppose we are trying to maintain the consistency and we are accepting the eventual consistency. So let's say we are trying to have a eventual consistency in our system. Then uniqueness. One short URL should be mapped with only one long URL. Then you have scalability. It should support scalability means our able system should be flexible enough, scalable enough to support a millions of URL generation, let's say in a day. So also a very important thing to note is low latency. 1, 2, 3, and 4. All of the four are very important non-functional requirement that a system should support. High availability, it should be scalability, it should support the consistency, uniqueness of the uh, sort URL in this case, and then low latency. Your URLs redirection, let's say, should work in, let's say, less than 50 milliseconds or so. Now, uh, back of the envelope estimation. So as we discussed, this is a very important step in a system design to understand, to approximate some of the key metrics and understand the requirement. For example, scalability requirement. Um, how many how many servers you need for your system, how many caches you need for your system, the bottleneck like storage growth, high QPS, then the trade-off. Should you use cache for high read loads, or should you use sharding for storage? Then the other metrics like resource planning. Are you going? What is the cost? What will be the storage required? What will be the memory, network bandwidth, etc. Then, as we discussed earlier as well, it helps you in deciding should you choose the monolithic versus microservices? Do you need to have a load balancer, replication, etc. So let's do a rough calculation and come to some approximate number for our system design. So uh, let's say we are supporting the write operation, which is equal to 100 million URL generation per day. Right, write operation means we are our service is able to convert a long URL into a short URL, which is equal to 100 million in a day. So what will be write operation per second? Write operation per second means in 1 second. So this is equal to 100 million divided by 24 divided by 3600, this seconds in a day, which is equal to 1160 records, let's say. Now, read operation. Let's say our system is read heavy. That means it supports more read operation than the write operation. For example, read to write ratio is equal to 10 is to 1, which means total read operation is equal to this much, 11,600. So in a day, system will support 1100, system will support 1160 records for the write operation, and 11,600 read operation in a day. Sorry, in a second. Now, assume that service will run for 3 years. Then how many records are required means how many URL generation our service should support for the next 3 years. So for a day, we have 100 million, and for a year, which is 100 million into 365 days and into 3 years, which is equal to approximately 110 billion records. So this many URL generation instances our system should support. So when we will try to um, do a rough calculation for our storage. So let's say each URL, uh, average of each URL size of URL is equal to 100, which means 100, which means uh, it will be of size of 100 bytes. Now, since we have this many URL in 3 years, then 110 billion into 100 bytes. It will approximately be 11 terabytes. So, um, uh, for our system to support uh, work for the next 3 years, our system should be able to uniquely generate 110 billions of record, and then we should have a storage of approximately 11 terabytes. All right. So after that, let's move to the high level design. Okay. So you have a client. There is a client which will which wants to convert a long URL into a short URL. It will send a request to API gateway. API gateway will forward the request further to the load balancer if we have a load balancer in our system. This is very important to have actually because we are going to support a millions of records in a day. So client will send a request to API gateway. API gateway will send forward that request to the load balancer. Load balancer will then forward the request to the URL shortener service. URL shortener first will have a for faster response. It will have a Redis which is in memory cache. It will check in the Redis, uh, is this long URL already exist? If yes, then it will return that long URL to the client. If no, then it will go to the database. There is a database and query the database to check if that particular long URL already exists. I mean, the short version of that long URL already exists. If yes, then it will update the cache and return back to the client the short URL. If not, then it will generate the short URL. And similarly, for the redirecting API, client will send, try to visit the short URL. The request will go to the service. Service will uh, return the client with the original long URL. So now the question is how system will generate a short URL. So actually, you have a long URL. Client is sending a long URL to the service. This will go through some hashing function, and then uh, this hashing function will generate a hash value for this particular long URL, and then that will be actually used for the short URL. We will discuss this more later. Before we will deep dive into some of these concepts like hashing function and etc. Let's discuss briefly about URL shortening API and URL redirecting API. So as we mentioned, two of the core functionality of having a URL shortener service is uh, URL shortening API endpoint and URL redirecting API endpoint. So this is a post request where user is sending a post request with a parameters long URL. Parameters is long URL. User is sending a request to the service to with a parameter long URL that converts this into a short URL. What it will do is service will generate a short URL using a hash function, let's say, and then store that into the database and return that short URL to the client. Now, um, we have another API that our URL shortener service to support is URL redirecting API endpoint. So this is a GET request, and URL is sending a request like get um, short URL, get a long URL for a given short URL. So system will again query the database. First, it will query the cache and try to find if this short URL already exists in the cache or not. If yes, then it will return to the client. If not, then it will go back and check the database. If you have that short URL in the database and there is a mapping with long URL in the database, it will return back to the client the long URL. However, if this short URL does not exist in the cache, does not exist in the database, then it will return an error. This short URL is not a valid URL that the system is going to support. Now, this short URL redirecting will happen in two ways. So, uh, system can redirect the short URL to the original URL in two ways. Redirect in two ways. One is with a status code 301 status code, and the second is 302 status code. What it means is when a system is sending a status code, redirecting a client to a long URL with a status code 301 redirect, this means this short URL has been permanently moved to a new location. Short URL has been permanently moved to a long URL. Now, it is indicating that this particular short URL has been permanently moved to the long URL. In that case, browser will cache those information, and any subsequent request to that short URL will not go to the service again, not go to the URL shortener service again. It can directly be looked into the cache, and then browser will redirect the client to the long URL. But in case of this 302, it indicates that it is a tem- temporarily move to the long URL. What it means is any subsequent request for that short URL has to go to URL shortener service first. It is useful in tracking the click rates. It is useful in tracking how many clicks are coming to this short URL, what are the source of clicks, what is the location of clicks, etc. So this is 302 redirect is important when we want to track and we want to get some information, analytics, tracking and analytics. 301 status code is important when we want to reduce the load on our service so that the browser can directly cache that uh, information, that the mapping of short URL to the long URL in its own cache, and the request will not go to the service. So this is how it works. Now let's deep dive into some of the concepts. So we briefly talked about hashing function. We briefly talked about URL shortening, uh, shortening API endpoint, URL redirecting API, and probably we can discuss some deep dive into those topics. So, um, okay, okay. So, in the deep dive, the first thing we are going to discuss is data model. So, having a hash table uh, is a good starting point in this system. Uh, but hash table, I mean, hash table to store the data. Uh, but hash table is a in-memory data structure, and which is in real world example, it is very expensive and limited. So we would want to avoid everything to store into the hash table, and therefore instead we will have a alternate option, which is relational database. So we will use a relational database to store our data. And for that one, we may design a system table with three attributes, let's say ID, short URL, and long URL. So for example, we have ID 1, we have some short URL ABC 123, some, and this is mapped to some long URL. Another entry we can have 2, XYZ 123, and then this particular string is mapped to some long URL. So um, my point is, um, having a hash table to store everything might be very very expensive, and as we mentioned, it is a in memory data structure, and which is we have a very expensive and limited memory. So we should design, we should have a relational database to store our data. Okay, okay, so let's discuss about some detail of hash function. We discussed earlier that this particular string to generate a short URL will be generated using some hash function. So the first point uh, to discuss about hash function is what should be the length of our uh, string of this string, let's say. So as we discussed, so that we can uniquely generate the 110 billion records, as we discussed in our um, data estimation, that we are, in order to support our system to run for the next 3 years, we are going to uniquely generate 110 billions of records. So for that, how many, what should be the length of our short URL so that we can support this many of records uniquely? So the answer lies in, because each characters have the option for 20 62 options, because as we discussed, there are numbers, 10 numbers that we can use, 10 lowercase alphabet we can use, and 10 uppercase characters we can use. Here we have 10, total 10 character. Here we have 26, and then 26, and total we have 62 options. So let's say we have some length of our short URL, and each position has 62 options, uh, options that it can take any character from the 62 available character. So in order to uniquely support 110 billion of records, we should we should be able to find a n where 62 raised to the power n should be greater than or equal to 110 billion. If you will do the calculation 62 raised to the power 5, it will approximately come to 900 million. 62 raised to the power 6 will approximately come to 57 billion, which is again less than 110 billion. Then 62 raised to the power 7 will approximately come to 3.7 trillion, which is much greater than 110 billion of records. So our n is 7, which means we are going to support, we should have our sort URL of length 7 at least, 6 and 7. So our sort URL string length should be 7 so that it can uniquely support the 110 billions of records. Now, um, there are two types of hash function that we can use, two types of hash function. One is hash plus um, collision resolution. And the second one is base 62 conversion. So we are going to hash a number, at string means a long URL, into a 7 length string, but and then we are going to resolve the collision. As the name suggests, there is a collision possibility of collision. Um, Two long URL may collide with same short URL, and therefore we need to resolve this collision. So every time you need to, for every request, you generate a sort URL and go and check in the database if the sort URL already exists or not. If not, then probably that is the uh, solution for the long URL. But if that sort request sort URL already exists in the database, you have to uh, resolve this collision. Append some predefined string to the long URL and then again generate a short URL. And we have to do this recursively. So as the name suggests, there is a collision possible and it is also a bit expensive to look into the database each time to check if that short URL already exists in the DB or not. And therefore, the better option is to have base 62 conversion. Why base 62? Because we have total 62 characters that are allowed to be used in sort URL generation, and therefore uh, we can use this base 62 conversion to uh, generate a sort URL. So how this works? Base 62 conversion. So you have a ID generator. So every time a request comes from a user to convert this particular long URL into a short URL, so it will generate a unique ID, generate a unique numeric ID. Maybe we can use Redis to generate this unique ID and then um, um, convert that or encode that ID into base 62 using this character, using these 62 characters, and then use that um, to use that to generate a sort URL. Save that in the database. Save that in database and return the sort URL to the client. Okay, so this is how this hash function will work. Now, if we will deep dive um, into URL shortener, URL shortening service, URL shortening service. So there is a long URL that comes from client. Then this request is forwarded to the um, URL shortener service. Now, what URL shortener service will do is it check, is this long URL already in DB? Yes. Then return to the client, because this means this long URL has already been converted into some short URL, and that can be returned to the client. If no, then generate a unique ID, rec unique ID, convert or encode that into base 60, encode into base 62, and then um, use that as a short URL, save that string into database, save in database, and then return to the client. So this is how URL shortening service may work. Before moving on to the hotkeys, we can briefly discuss about URL redirecting service as well. Okay, so there is a client which sends a request to API gateway. It forwards the request to the URL shortener service. It first checks the cache. Let's say we have Redis. If that short URL exists into the cache or not. So this is the step one. This is the step two. This is the step three. Check the cache. If not, then check the database. Step fourth, if it exists in the database, then return that to the client. Redirect with either 301 or 302 status code. Redirect to the long URL. So this is how URL redirecting service works. So we briefly discussed about data model, we discussed about hash function, we discussed about why we should avoid the hash plus collision resolution type of hash function, and we should choose the base 62 conversion method. And then we discussed about URL shortening service, URL redirecting service, etc. So pretty much we covered all the important concepts of URL shortener service. Now, as we discussed, we will be discussing a very important questions related to hotkeys. So if you are in an interview, interviewer may ask you, how do we handle, how would you handle a hotkeys when a particular short URL becomes, gets a massive traffic? How are we going to handle that? So hotkeys, how would you handle hotkeys when a short URL gets suddenly gets a massive traffic? So how are you going to handle that? In real world example, a URL posted by a celebrity can receive 80% of total traffic. Then what it will do? It will increase the suddenly it will increase the load on our system. So the first line of defense is having cache. We can use the distributed in memory cache like Redis, and avoid DB, the database rate. So as much as possible, we should minimize the database rate, and we should have the distributed in-memory cache so that all the read operations should go to the cache instead of database. Then the next is when we have the extreme traffic, we can implement we can use consistent hashing. consistent hashing. What it does is it tries to distribute the load across multiple nodes. So one particular node will not get a lot of traffic. The load can be distributed across multiple nodes. Then in the next step is you can redirect the request to the CDN. To CDN, it distributes the request geographically. So one particular location will not get a lot of traffic. Wherever the click is coming from, the load can be shifted to that distributed across geographically. And the next step is proactively track. Proactively track hotkeys and try to figure out what are the emerging hotkeys so that we can uh, if we can refresh our cache with the new emerging hotkeys and avoid database load. The next option is mm, just if doing all these steps, having a cache, having a consistent hashing, using a redirecting request to the CDN, and proactively tracking the new emerging hotkeys, detecting new emerging hotkeys, and refreshing the cache to avoid the load, the thundering herd on our database. If doing all of this, uh, even doing all of this is not working, then we can request a lock. Request a lock. If we are still facing a load, if our database is still facing a load, we can request a call so that only one request from the cache will populate and go to the database. Last option is deny the service gracefully, which is 503 temporary error. All right. So my question was, how would you handle hotkeys when a particular sort URL gets a massive traffic? How are you going to handle this? So the first line of defense is caching. First line of defense is caching, and then the next is using consistent hashing to distribute a load across node. Then redirect the request to the CDN to distribute the load geographically. Then proactively track the click and detect the emerging hotkeys so that we can refresh the cache with the new hotkeys. And then if we are still unable to resolve the issue, and if our system is not in a good health, then we will request a lock so that only one request will repopulate from the cache and will go to the database. Then even if we are unable to bring our system into good health, then we can gracefully deny the service with 503 temporary error. All right. So this is it for now. We pretty much discussed everything about URL Shortener service. We discussed what is it, we discussed the benefit and the requirements, then we moved to the high level design. We did some approximation to understand how we can support our service to run for the next 3 years. Then we discussed in depth about hash function, data model, URL shortening service, URL redirecting service, and we discussed a very important question related to hotkeys.